Really good questions during the break. So do come up with questions during the session as well. That way we can all participate on it. So that's very good. So getting back to the, where did we leave? Where did we leave? Where did we stop? Functional style, thank you. Yes. So one of the nice things about functional style is we are going to promote the assignment-less programming. But also, we deal with higher order methods. What does it mean by higher order methods? We can do to functions what we have been doing to objects. You can pass objects to functions. You can create objects within functions. You can return objects from functions. Now you can pass functions to functions, create functions within functions, and return functions from functions as well. So let's think about this for a minute with some examples. Let's say for a minute we are interested in using, let's say, talk about Java for a second. So if I want to create a Java code and assume that you are within a main method or whatever, it doesn't matter, right? So let's say we are interested in taking a group of numbers and we want to iterate through those numbers and print them. So we could do this using a list of integer. And let's say we can say numbers, right? And then let's say this is new, let's say this is new, or arrays as list, let's say a bunch of numbers, something like this, right? Now, I'm going to talk just a little bit about Java 7 for now, or earlier. Do you have Java 8 on this machine by any chance? You do? You are my friend today. Awesome. And is it in your class path? Or is that the default? Do a Java minus version here. Okay, can you put it to 8 for us? Yeah, can you? Yeah, awesome. This is awesome. This man is from heaven. I don't have a problem with my machine crashing if he's going to come with me everywhere I go. This is awesome. Very cool. So the beauty is you can write functional style of coding in almost any language today, by the way. It doesn't matter. Even including Java. In this case, of course, I'm including Java 8 in this fold. And the beauty is that you can write functional style of coding. So what does it mean? You are, rather than working with functions separately and objects separately, you are composing your application not just using objects, but using functions, if you will. And this gives an opportunity for us to design a little differently in a lightweight manner. Excellent. So let's get to this and say Java minus version. This is wonderful. You are my dear friend. All right. So here's an example. Let's say Java. And I'm going to say public class sample. And of course, public static void main string arguments. And let's create a list. So list of integer, let's call it numbers, equals new, let's say arrays dot as list of some numbers, right? So given these numbers, question is, how would we iterate over these numbers and print them? Let's import java.util.star for a minute. So how would you iterate and print these numbers? Let's give it a try, can we? For int I equals 0, I less than numbers, you could do that, right? Rather than going through that pain, you can simply say numbers dot for each in Java 8. And you can give it what's called a lambda expression. Given an element, I want to print out system.out.println, and I want to print that element out. So we are passing a function to a function in this case. And for each, by the way, is a higher order function. Why? Because to this function, we are passing an anonymous function right here, as you can see. So think of lambda expression as anonymous functions. And let's see if this is going to work. So Java C sample.java, I'm compiling the code. Notice it quietly compiled. It is quiet like a well-fed baby, right? It didn't complain to us. And I run sample over here. And right there's the output. So that is lambda expressions working in Java 8, as you can see, right? So let's go back to that code for a second. Let's try one more time. If you want to double each of the values in this collection, has anybody taken a collection and doubled the values ever? Have you done that? Everybody has done it, right? Yeah, you're reluctant in raising your hand, but I can see you nod. I can see why you are reluctant. What do? You say list integer doubled equals new array list of values. That's the first thing you do, right? Then you say for int element in numbers. And then what do you do after this? You say doubled dot add element times 2. And then when you're done with it, you say system dot out dot print line, and then you print doubled. Sounds familiar? We all have done this, right? So you compile the code, and then you run the code one more time. So here is sample I want to run. Uh-oh. Uh-oh. What did you do? From here? All right, thank you. Okay, let's try this again. So Java C, sample.java, and then Java sample. So we wrote it, it worked. But let's get back to the code for a second, can we? What do you think of this code? It's ceremony. How do you feel after you write this code? Dirty. Right? You go home and the kids come running to you, say, don't touch me, I got to go shower first, right? It feels that way, isn't it? You don't have to do that in Java anymore. Get rid of that. And instead you simply say, here is the value, I want to print it, and what are you going to do? This is Java 8, right? You're saying numbers dot, and you can use a map operation. And you can say map, and what am I going to map to? Map to int. And I'm going to map element to element times 2. So you can ask him to perform the mapping right there. And then you can ask him to collect the result back to you. You can say then, you can say collect. And what do you want to collect this to? To an integer collection. You can say to list, right? So you can ask him to perform operation like this. And assuming I got the syntax right, depends on the version of Java. Remember, Java 8 is still evolving, and so we have to make sure I'm writing the correct version. So let's go ahead and add a couple of things here. Well, I'm first of all using a map to, so that comes from a fancy iterator called stream. So I'm going to bring in stream first of all here, stream. And I'm also going to bring in a static import over here. So let's say static. And I'm going to bring in static import to a collector and bring all the methods of it. I'm not sure if I got the syntax right, but we will see. Though it didn't really like it. Collect is an interface on int stream. I'm not sure what version, like I said, I'm using here with the changes made, but I'll give this one more try. I'll just use map here for a minute. So stream.map, and I'm asking to go through the map of collections. In this case, I'll say go to the integers. Let's say integer. There we go. And I may have to put that back in there. We'll see. So what's he complaining about? Of course, I have one more extra parentheses there. Let's get rid of that. There we go. So the point really is, all right, I give up on this. But the point really is that you're going to use a fairly lightweight syntax, and you can use functional style. Even in Java 8, you can do this, by the way. Of course, Java 7 doesn't provide that. So what does functional style do? It can enable enormous amount of parallelism if we wanted to achieve parallelism. It can help us because we're going to honor immutability in code. So functional style of programming can give us a lot of benefits. So, and of course, functional programming has been around for a very long time. And so, where's your browser, my friend? This one here? All right, thank you. So, how important is functional style? Well, I would actually place it fairly high, actually. So, let's say I want to give it 8 points for a minute. If I do, Java 7 doesn't get many points, by the way. I would say it is kind of 0 for functional style of programming. Yeah, you can use anonymous in your classes, but anybody so excited about using anonymous in your classes? No, he was raising the hand, but he's scratching his head, no. All right, what about Java 8? You can go fairly full-fledged with it. Groovy, Scala, all these languages have been having functional style from the get-go. So you can see that Java really falls really low, but Java 8 stands up to it fairly well, right? It can. The next thing I want to talk about is immutability. By the way, why should we worry about immutability? Well, mutability is where we modify variables. What happens when we modify variables? Bad things begin to happen. We are smart people, right? But we are smart, we are intelligent, but we are not, to err is human. Our mind cannot completely think about all the sequence of things that happen in the code everywhere. And you modify a variable here, and suddenly you're like, how did that change over there, right? It becomes really hard. And multi-threading is very difficult when we deal with mutability. I got a separate talk tomorrow. You're going to be here tomorrow? I mean, I need your computer. I'm going to talk about concurrency tomorrow, where I'll go deeper into immutability and related details. But the point really I want to make here is that immutability is better. Now, would you ever hire anybody for a Java job if they've not read effective Java? You wouldn't do that, right? And the interview you say, have you read effective Java? And if the person says, what is effective Java? What do? You escort them out of the building right away, right? You don't talk to them anymore. Well, what does effective Java say? As much as possible, make your fields final. As much as possible, make your objects immutable, right? It says that, right? Well, that's a good practice. Now, how do you make things immutable in Java? By making them final. So you have to make things final, isn't it? So if you're writing Java code, so what would you do in Java? If you're defining a variable of some sort, you would have to say, for example, final int some value, right? You have to say this. What if you forget to put final? Will the compiler tell you that? Not really. So you have to remember to do this, right? That's correct. But let's think about this in Scala for a second. In Scala, by the way, if you're going to define a variable, something equals to, it says, what are you doing? What is something, by the way? Oh, it's a variable. Well, type inference is there. What happened? Scala says, you don't tell me something is a variable, first of all. So in Scala, you have to say either var something equals 1, or you have to say val something else equals 2. What's the difference? At the get, it stops you and says, you decide now. Do you want mutability or do you want immutability? By the way, var is also known as a variable of shame. If you write var, you have to put your hands down, head down, and you have to look on the floor and say, I did that, right? It's a variable of shame. You should feel bad about it. Val is noble. You're saying it's a value, I don't modify it. Now, beauty is, at the get it says decide, right? You cannot change it once you decide it's either mutable or immutable. But here's the beauty. You can quickly do a grep and say, tell me everywhere there is a var, I'm going to do a code inspection. And I'm going to come to him and say, excuse me, why are you using a var? No, it's okay. You're in a safe environment. So why are you using a var here, right? I can ask the question, and he says, well, here's a good reason, Venkat. All right, that's fine here, but I'm keeping an eye on you, right? Well, we can do an inspection. How do you know if you're using a mutable variable in Java, by the way? When I wrote my Java concurrency book, somebody tweeted, he said, oh my God, I'm looking at Venkat's book. He's got 300 use of the word final. And I tweeted back saying, but you don't know where I still forgot to put it. I remember that afternoon when I was about to go to the print, I went through the entire code looking for everywhere I forgot to put the word final. That was the lowest point of writing that book. It was very boring, right? But in the case of Scala, you can quickly do an inspection. Notice here, I say something, right? Something equals, 22. Sure, no problem. Something else equals 44. There is a problem. You cannot modify this variable. Why? Because it's a value. It's immutable. Same thing in closure, by the way. In closure, let's go to closure here. Which one is that, my friend? That one. Oh, yeah, it says closure. Thank you. Let's say in closure, so Java minus jar, closure.jar. So in closure, I want to define a variable. So define, let's say foo is 4. So we defined a variable called foo. Print line foo. I print variable foo. Now you tell me, Venkat, change the variable foo. I'm sorry, I cannot. Well, why not? Because it's a value. I cannot modify values. So the language enforces it because it's functional style. Immutability is better. So in Java, you can change anything you want to. So Java 7 is dysfunctional in a lot of ways, right? Java 8, you still have to work hard to make things final. They do a little bit of work. Within a lambda expression, if you're calling a variable outside scope, they will ensure that is effectively final. They do that. But you still have to put effort to make things final in a certain way. In the case of Groovy, by the way, same problem. You have to, I'm sorry, but I keep moving. I'm not giving a rest to the cameraman over there. But that's the way it's going to be, sorry. So the point really is that it is going to be our effort, by the way, in Groovy to make sure it's immutable. In the case of language like, same thing in JRuby, by the way. But in the case of Scala and Clojure, there is better control over immutability. And as much as possible, we should use immutability. Here's another thing I want to show you, by the way. Let's say we are writing Java code here for a second. So let's say this is Java code. So here is a sample.java. And in the Java function, let's say for a minute, I'm going to say a public class sample, let's say. And let's say in this function, I have a function, public, void some function foo int a. And within this function, I got several lines of code, let's say, right? Several lines of code. And suddenly I go crazy. And I say a equals 2, and I write more code. Have you ever seen code like that, where people modify the input parameters given? Sadly, yes, right? Now, why is this wrong? This results in bugs a lot of times. I had a day when somebody called me up and said, I wrote this code, I can no longer understand why it doesn't work. Can you help me? So I'm looking at his code, and I'm like, this doesn't make sense. And he's like, yeah, right? Why doesn't it work? Now, we both are scratching our head. And after about 15 minutes of looking at this code, we start stepping through every line of code. And suddenly, like, whoa, wait a minute. Did you just change the input parameter? And he's like, yeah, I didn't even realize it. Because it's so morally wrong, we don't even look for it, right? Now, let's think about this for a minute. So what do you recommend in Java to do, by the way? You say, go ahead and put final over here, right? Isn't that what you say? Have you ever wondered this? You read effective Java book, and then you say, if effective Java says so many good things, why didn't they make Java effective? Actually, they did. They took effective Java book, one each, every step they looked at it and they fixed Java. And when they finished it, they called it Scala. So let's take a look at an example here, right? So here is Scala, and I define foo over here. Let's say define a function, and I say a:\int. So right there is the function I defined, right? And here I want to print a. Right there I printed a. So right there I call foo, and I send a 2 to it. It printed 2. Let's do this again. Define foo, a is int, and this time, by the way, I'm going to say, one more time, I'm going to say, print line a, just like I did, but this time, sneakily, a equals 666. Right? Notice the compiler says, how dare you? Are you trying to change the input variable, input parameter, right? It says no. I don't know if you saw it from there. It slapped me on my hand and said, bad boy, don't do it. Because that is the right thing to do, right? Honoring immutability on the input parameter is very important. And says, that's what I'm going to do. So you may say, hey, Venkat, this is nice, but is it possible for me to still change the input parameter? What was that? That's right. Go back and program in Java. Well said. Absolutely. And Scala says no, because that's morally wrong. So immutability is a good thing to honor. And so what about monitoring immutability? I'm more interested in emphasizing immutability, right? So you can give a weightage for it. You can say, I want 8 points for immutability. What was that? 1 up. Did I change the wrong one? This one. This is mutable page. What can I say? Right? 8 points for that. And what about Java, by the way, in terms of immutability? 5? Okay, final, right? All right. You better be ready to write a really good grep command. This is not a whole lot better, maybe 4, because a little bit of help in the lambda expressions. Closure, I would bump it up. Groovy, I would give still the same as in Java, 4, maybe 3. What about JRuby? Even worse, 1. What about Scala? I wouldn't give a 10, by the way, because you can still put vars, right? So I'll give a 8 maybe. So you can kind of compare that and decide which is a better one to choose based on that. And then, of course, managed mutability. What is managed mutability, by the way? This is one of my favorites. Managed mutability says, one of the problems is this, right? You say assignmentless programming, no mutability. And you're sitting there and wondering, I've been programming in Java for 15 years. I live in mutability. How could I write code where nothing changes? And then the functional programming gurus come to you and say, we do it. And you tell them, really? Yeah, we write code where nothing is mutable. And you listen to them and say, what are you guys smoking? How could you write code where nothing changes? But these guys are very clever. They say, of course everything is like that. We use monads. Now we have no clue what they're talking about, right? Because they use that M word on us, monads. So how do they do it? Well, in the meantime, we got a real production system to create, right? Well, is there a way to solve this problem? Tomorrow I'll talk about what I would like to call as isolated mutability, so I won't go into that today. But STM, software transactional memory, introduced in JVM through Closure. It's been around before, but Closure brought this to the Java Virtual Machine. It's pretty interesting. So let's look at Closure for a minute. If I go back to Closure here, I really lost it this time, didn't I? Oh, go ahead, please. There we go. So let's try this one more time. Remember, I told you earlier that I cannot modify foo, right? Define balance. I create a ref 0. What is this ref, by the way? Ref is a managed mutable identity. And so as a result, I can say a print line balance, and notice in this case, it's a ref object. I can dereference it. I can say print line, and in this case, I can ask him for the value of balance. Notice it says balance is 0. But if I say ref-set balance is 100, it gets really angry. It says illegal state exception, no transaction running. I cannot just walk up to this variable and change it. If I do, it screams, he touched me, right? And it tells everybody, look what he's doing to me, he's mutating me, right? So notice it blew up on my face. So how do I do this? Well, before I can change a variable, I have to enter into a transaction, do sync. And I say do sync, and then I say ref set. In this case, balance is going to be 100, but notice I did this within a transaction. Now I ask him, what is the value of balance, by the way? So print line balance now, notice in this case, the balance value now is 100. So the point is, it protects us. It makes the reference a managed immutable identity. How does it do it? It gives you an identity, values are still immutable, identities are mutable, but only within a transaction. An identity points to an object. Objects cannot be modified, but in a very safe environment, you can reset the identity to a newer value. When multiple threads compete to do this, all the threads can enter transactions on their own. If one transaction finishes, the other transaction will also finish if they don't compete for the same data. If the two transactions are competing for the same data, one of them will finish and the other is automatically retried without us having to write any code. So this makes mutability much safer. But for us to be able to use this, by the way, we have to make sure we keep the functions pure still and only mutate managed mutable identities. So in other words, this gives a managed mutable identity. Java, what about Java? Does it give that to us? I heard a 0, but here's the beauty. Well, there are libraries for it. Well, tell me what there is no library for in Java. It's called multiverse. Multiverse is available in Java. You can use that. You can also, by the way, don't even have to do that. You can just refer to closure.jar from within Java code, and you can use this as well, please. You can use Arca, which in turn relies on multiverse, and of course they're trying to make some changes to it. But there are several ways to do it. So yes, you can do that from Java, but the biggest pain in Java is there is no immutability by default. You have to be very careful. So I'll give a 5 for that reason. You can do it, but it's risky. What about Java 8? Doesn't change it, 5. What about Clojure? Of course it provides really well, but I'm not going to give only a 8. Why? Because from Clojure you can still get into Java code and mess up things. Right? Got to be careful. What about Groovy, by the way? It doesn't provide it. You can still use the closures, or you can use gpers, which uses multiverse under the hood. You could do that. JRuby, same thing. You can use Clojure or multiverse. And Scala, same thing. You can use that. Maybe a little bit better in Scala, so I'll give maybe 8 points for it, because you can check for values, and you can tell what the weightage is. Depending on what you're trying to do, you can change your weightage, right? If this is something you care about, if concurrency is important to you, if shared mutability is important to you, bump the weightage high. Otherwise, bump it low. And then you can see which one makes sense based on what you're trying to do. What is metaprogramming, by the way? Metaprogramming is where you can ask a program to amend, to make changes at runtime. So let's go to Groovy for a minute to look at an example of this. So I'm going to go to stir equals hello here, and now I'm going to say stir dot length. Notice it tells me that length of the string is 5. Stir dot shout. It says, what are you talking about? I don't know what a shout method is. Now I'm going to say stir dot meta class dot shout equals, and I'm going to say delegate dot to uppercase, So I just wrote a method for myself. Now I say stir.shout. Notice how I injected a method into a class. You're like, what class did you inject it into? Stir.class, the sacred Java lang string class. Why not? It's our code, right? So this is called method injection. Not only can you do method injection, you can do method synthesis. What is method synthesis? You can ask the objects to synthesize, to simulate methods at runtime. By the way, that's what tools like Grails use. They assimilate behavior on the fly. And so you can call methods with certain conventions and they come to life. Now, metaprogramming, you can evaluate that too. Language like Clojure, Groovy, JRuby give you that very well. Scala not so much. They're working on a few things in Scala to enable that. But right now, these languages are very powerful. Right now, if you only look at the landscape, the dynamic languages give you metaprogramming, static type languages don't. But we're really hoping the Scala will change that landscape. We'll see. But why is this so important? I talked about how tools like Grails use it, but I'm going to argue that fluency is very important and metaprogramming is very important because DSL to me, when I say DSL, internal DSL, meaning a language can support domain-specific languages, is equal to fluency plus metaprogramming. This combination gives you enormous capability to create internal DSLs. And so if you're interested in creating internal DSLs, I would highly recommend a language which is fluent, low ceremony, no semicolons, no parentheses, right? All those characters that are not required, which really hurt our eyes, remove them. And then introduce metaprogramming. Now you can create very effective DSLs. So to summarize what we talked about, I'll post this tonight, by the way. Well, okay. Are you coming with me tonight? Assuming I get my machine recovered, by the way, and as I was speaking, I was actually recovering the machine, and it is actually just about recovered, I think, almost. And assuming that it comes to full recovery tonight, I will post this for you. You can download it from my website, which is agiledeveloper.com, and you can download the spreadsheet that you see here from my website, agiledeveloper.com, and there's a download page there as well. You can get it from there. And what you can do in this case is you can try this sample, right? What are these features? How much weightage I want to give? And then you can pick and choose what language may make sense to you. And keep an open mind, like I said. So we looked at a number of these features so far. So what are the features we talked about? We talked about static and dynamic typing. We talked about low ceremony. We talked about function style, and then of course immutability and managed mutability, and metaprogramming and fluency. Fluency is where you don't really have ceremony at the code level. And then based on these things, so here's the beauty. All the languages on the machine compile down to bytecode. So as a result, you are looking at bytecode. For example, if you're writing Scala code for a minute, so you could say, for example, sample.scala. And right here, I could say, for example, noted, thank you. So I could say, for example, a class, my class over here. And in this case, I'm going to say Scala C and sample.scala. And notice on the disk now, I see my class dot class. I can say Java P minus C, my class, and I can take a look at it. If I hit the tab, it seems to be frozen, actually. There we go. So Java P minus C, my class. And you can see the bytecode that was generated from Scala. Same thing with Groovy. I would say Groovy C to compile the Groovy code. So all the languages on the JVM compile down to bytecode. So people ask me, how do you integrate code between these languages? It helps me to think about, how many of you use Hibernate? Of course, everybody here does. How many of you use Spring? Of course, everybody does. So you already have 100 jars in your class path, right? So you just put one more jar in your class path, a Scala jar or a Groovy jar, depending on the language you're using. And then once you compile the code into the bytecode, have it in your jar, class path, have a jar to the language, and then you can intermix these code fairly easily. So you could write an enterprise system where you could have a lot of your code in Java, assuming it's legacy, but you are sitting there and working on something and you say, you know what, Scala would be a better choice for this, or Groovy is a better choice because I want to use a DSL. You can write that part alone in Java, or I'm sorry, Scala or Groovy or Clojure or JRuby, and then you can compile that into bytecode and then intermix it with your application. So you could have part of your application in one language where it makes sense, and the rest of the application in another language. So we don't live in this all or nothing world. We have a nice way to pick and choose combinations, and kind of like when I travel, I took an airplane, and then of course I also took a taxi to get down here, and of course I would like to take my bicycle to the park. So if I think of languages as vehicles of transportation, it gives me the power. I could be afraid of these languages and shy away from them, but remember, we are professional programmers. We want to use the right set of tools to solve the right set of problems. The goal is not to use these languages. The goal is to be more productive and get better with what we do. And the fact that these languages are available to us gives us the power. And it's our right to use them if we choose to, and it's perfectly okay if we don't want to use them for a good reason. But if fear is the ruling factor, or ignorance is the ruling factor, then certainly we need to fix it. And we can pick and choose the language that may make sense for what we want to do, and that is certainly available to us. And once we do, we can then decide what language is right for what purpose. And we got some beautiful tools available to us. You know, you mentioned about Akka. Certainly we could use Akka. We could use STM from Clojure directly if you wanted to. We could intermix Scala capability for handling XML documents really well. We could use pattern matching from Scala in the code. We could use Groovy's metaprogramming if you wanted to, or JRuby's metaprogramming if you wanted to. And that is the fun. It is power to us, the programmers, right? So if you look back in time, back in early 2000, if people got tired of programming in Java, they had to turn in their passport, right? They had to sell their house. They had to give away their pet. And they had to emigrate to this unknown land. Well, we don't have to do that anymore. We could sit where we are sitting, and we can say, I want to reach out and use these languages. I don't have to move a muzzle. I can sit where I am, and I can use these languages. And there is another reason to pick these languages, by the way. Not so we can go back and program in those languages. It is because if you learn a different language, I guarantee you, you will never program in the language you program in the same way. I don't write Java code anymore the way I used to. The fact that I was influenced by these languages, I write Java code a lot differently, and I hope a lot better than I used to. So learning these languages not only helps us to use those languages, learning these languages also helps us to program in the language in a lot better way as well. And of course, I could not have done this but for your help, so thank you very much for your help. Appreciate it. Thank you. We do have a few minutes for questions. Is that good? Yeah, if you have questions, I would love to hear your thoughts, your views. Please.
Don't know anything else but Java. And the manager. In a real world development, Venkat, you know, there are most of the people who don't know anything but Java. I can give an example. We have an application with a build script that was written in Ant, but one part of that build script was written in Python. That person who wrote it is gone. So if we will take that HTML table of yours, which is great, if we will add 2 more rows, labor market and community.
This is a very good question, by the way, but I'm going to say that if I have a team of people who know only one language, I have a bigger problem already on my hand. And the reason is, imagine this for a minute, right? This is nothing to do with this particular talk itself. This is a bigger problem to deal with. If I'm sitting on a couch and eating potato chips every day, and I've done this for 3 years, and a friend of mine walks in and says, hey, Venkat, it's a beautiful weather outside. Do you want to go for a run? I'm going to say, run? Do me a favor. You go on the run. But before you go, could you get me another pack of potato chips and then go, please? Because I'm physically not able to move my muscles. If I really want to be healthy, I got to get around. I got to start. I know what I hate being on the treadmill. It sucks, but I do it every day.
I agree.
Mental muscle is extremely important. If somebody doesn't learn new things every day, they're going to become really hard to change, even in the language. I bet you, when Java 8 comes, those people you mentioned will have a hell of a lot of difficult time learning Java 8 because they only know the old Java. So this is a very difficult situation to be in. I would say if you are in a team like that, please do not walk away from the team. Run.
And who's going to pay my bills?
That is the least problem. I would rather starve than have a job like that.
Okay.
That's my personal opinion.
Anyway, I think that your talk is really important because it gives a perspective. It may force other people to start learning different languages. I agree with you, but realistically, it's very difficult situation in the enterprise development.
It is difficult only if we want it to govern us. But the cost of doing it is there. I'm not going to say no, but the cost of not doing it is enormous. And as a professional programmer, we definitely don't want to be in that situation. It is trouble. There was another question here in the front.
I have a question about managed mutability. When you discussed it, you mentioned only STM as a solution. So the question is, can we say that, for example, actor-based concurrency model can be called the managed mutability?
I call it as, I did mention on the fly, I didn't talk about it much today. I call it isolated mutability rather than managed mutability.
Isolated, yes.
Yeah, and I have an entire talk about this tomorrow.
I mean, I just asking because, for example, actor-based concurrency model also serialize the access to internal data, and
there are pros and cons of it. There is the beauty about STM is readers win. Readers are never blocked. STM is a great model when you have frequent readers, frequent writers, and very infrequent write collisions. Actor-based model punishes the readers. Every reader has to line up behind other readers because only one reader can go through. So actor-based model is good, but there are some limitations to it as well. But I'm really avoiding that because it is too much to get into right now, and I have a separate talk on it for a good 90 or 100 minutes tomorrow. And one last question I want to take, because you had asked one.
Of Java, sorry, of these JVM languages like Java interoperability, I mean, ability to integrate with existing Java code, and so which weights or numbers would you give to this language?
That's a great question. I want to emphasize one thing. The list I gave you is not comprehensive. And the reason is, a lot of times people come to me and say, which would you choose? And I tell them, I don't want to choose for you. I want to just give you a tool to choose. So please do add more rows to this to choose different items from it. And one of them would be performance. One of them would be interoperability. Surprisingly, as much as statically typed Scala is, it is a bit painful to integrate. And the reason is there are quite a few things that Scala does that seems to interfere with our way of thinking in Java. So interoperability is a little bit more painful in Scala unless you really get a little used to it. Groovy has the smoothest of all integration. Groovy follows the semantic model of Java. In fact, most of Groovy code is Java code. So you can literally take Java code and run it as Groovy also, except in a few places where it'll be a little troublesome. For the most part, it'll work. So if you put that as a count, and that's a good thing to do, by the way, you would see Groovy very high in number, Scala somewhere in the middle, and JRuby would also be, between middle and high, and Clojure, from Clojure can go into Java very well. From Java into Clojure is not that simple. because Clojure doesn't promote an object model as much as promoting a functional style model? Really good question. That's all I have. Thank you very much.